All right, guys. So just going over the Daphnia Lab, you should have your two hypotheses. If a Daphnia is given caffeine, then its heart rate will, whatever, increase, decrease, remain the same. If a Daphnia is given alcohol, its heart rate will increase, decrease, remain the same. Then going down, we took the data, we put it into the data table. You were then to make a graph of the caffeine. So I can do that down here. I'll paste that in, and then I need these two numbers. And paste them in, boom. And then I highlight them. I go to chart. And I gotta fix this up a little bit. I gotta go down here, which I've shown you before. You gotta mess around here a little bit. Get that out of the way. And you get that, and you can change the color. You also needed to change this over here. This was not the, I don't want the chart title. Yeah, I should say caffeine versus normal Daphnia heart rate. All right, and the vertical axis should have been heart rate. You say BPM, beats per minute, and you're done, really. And then you just copy that onto there. All right, get that out of the way. Shoot. And you would do the same over here, okay? And you would have a different, just copy, paste. And then you can do these guys here, copy, paste, highlight them. Shoot. Oh, I don't want that. Highlight them. Chart pops up. I go down here again, get two things. I don't know why they come out different colors. You can click on these and mess with them, but remember you want to go to, I want to customize, access and title. I don't want that. I just want it to be so the title of it should no, just normal. Yeah. Right. And I also want to do the vertical axis, and that is heart rate. You say BPM, beats per minute. All right. Copy and paste it, and you're done. Okay. You got normal versus alcohol. You could fix this a little bit if you want. Okay. Alcohol. Put some space in between it so it pops up on there. And you just copy and paste it, and we're done. All right, and that's it for that. And so going down, what was the independent variable? The independent variable were the substances we put on. In this case, it was caffeine and alcohol. All right. What's the dependent variable? It's the Daphnia heart rate. If you put it into the sentence to check, it makes sense. The Daphnia heart rate depends on giving it caffeine or alcohol. Two variables that should have been kept constant. You could have said the light, don't shine the light on it because that messes with the temperature. Using the same amount of alcohol, each group, right? A drop or whatever it was. Same time of day, whatever, same species of Daphnia. Maybe that has an issue, whatever you came up with. I don't think anybody lost points there. The control, again, the control is the normal heart rate, okay? This is the control. Some of you still are having trouble with that. It's what we do to compare, how we compare. We're not going to know if caffeine has an effect if we don't have a normal one. If you just give it caffeine and come up with this number, how are you going to know it has an effect? You need a control. The control is always what we're comparing it to. All right. Conducting studies called a model organism. Again, you can do a model. You can check it out. Model organism are all these organisms. We use flies and worms and Daphnia. It's to model something, to check out. We use these things because they're easy to grow. They have similar effects on them than on humans, something like that. Think about the numerical change. Do you believe you'd see the same effects in humans? Explain why or why not. You know, pretty much if you looked it up, you'd see, yeah, the answer is yes. Okay. We have a heart, has receptors on it. The receptors are respond to things like caffeine and alcohol. All right. All you have to do is look up studies and see how they affect us. There are many substances made in the body that act as stimulants and depressants. Propose a situation where your body might need to produce its own stimulant. Most of you won't with the fight or flight thing, right? Yeah. If you got into a situation where you had to act, right, real quick, your body produces adrenaline. Adrenaline is a stimulant. It stimulates our body. It increases our heart rate, releases glucose into the blood, gives us energy to deal with that situation. We actually have depressants too. I didn't ask you to do that, but they believe like people calm breathing can actually calm us down, that we release certain things that calm us. I know there's people who, like when they go jogging, they release things called endorphins, makes them feel like real nice when they exercise. I don't know. Why start with a new Daphnia? Because if we had a Daphnia, did its heart rate, put caffeine on it, counted, and then put alcohol right on top of it, the caffeine would still be affecting it. So you're not sure, your results would not be clear that it was the alcohol affecting it if it still has caffeine in its system. All right, so you need a new Daphnia. Why do we test new drugs on other organisms before testing on humans? Because they could be dangerous. I mean, I hate hurting animals, but if you do 100 mice and you give them some new drug and half of them die, clearly you don't want to be giving that to humans. Not that that's a cool thing to do to mice, but it's what we do. Okay. What can be concluded about alcohol and Daphnia heart rate? Well, if I go back here, go to our chart. Caffeine. All right. Caffeine I can conclude that caffeine will increase the heart rate of a Daphnia. The normal heart rate was 145. The experimental heart rate was 190. It says include the evidence. This is the evidence. Some of you are ignoring that and you got points off. What can we conclude about alcohol and Daphnia heart rate? Include the evidence. When Daphnia is given alcohol, its heart rate decreases. The evidence is it's 172 for the normal heart rate. When alcohol was given, it's 126 beats per minute. That is a decrease. And lastly, some of you are still not getting this. Some people are saying, oh, give it caffeine, give it tea or coffee. Well, why are you saying that? Tea or coffee, they contain caffeine. We just did that. All right. There's a lot of other things you could do. You could say a completely different chemical. What if you gave cocaine? Or what if some of you were good? You said, what about temperature? Does temperature affect its heart rate? Or what about light or dark situations? There's so many things you could test. You could have also said, I wonder if a mouse's heart rate would be affected the same way. You could do that. You could test it out. All right. There's many different things you do. Some of you're not getting that when you're really doing the same thing. I know it's coffee or a high energy drink, but it's still caffeine. Okay. So you want to now write down what you got wrong in the final question. All right. Tell me what question you got wrong, and you need to explain why you got it wrong. If you got tell what you did here. Okay. Remember, if you did, when you do a graph, you might have lost points. You say, oh, I put the graph in, but I lost points. Well, did you do the y-axis normally? Okay. Did you have a title on it? All right. If you didn't do that, that's why you lost points. All right. Otherwise, pretty much everybody who did it did a nice job on this. Good. All right. So do your little fixes ups on your lab and tell me what went wrong. And good job. All right, guys. Bye-bye.